In OpenStax Calculus Volume 2, at the back of the book, or if you're looking online, it's listed in the appendices of the book, there are derivative and integral tables, which are just your formulas. And I want to go back through and do a quick review of some of these. So talking about derivatives, which was early in Calc 1, we have the constant rule, which says if y equals any constant, so let's say it equals 4, then the derivative, dy dx, is 0. If I add two functions together, then I can take the derivative of each function separately. The product rule is a little bit different. I'm going to rewrite this as f prime g plus g prime f. And I know that you should have that of x in there, but this is a quick and easy way to write it. This one is another big one that we need to talk about. If y equals x to any power, so let's make it, I say any power, that's not actually true, but let's make it x to the 4th power. Then to take the derivative of x, or dy dx of the function, the 4 power comes around to the front, you keep your x, and you subtract 1 from your power. So there's our derivative. Here, the constant multiple rule basically says if my x has a constant multiple or a coefficient, so y equals 3x squared, then I take the derivative, dy dx. The derivative of x squared is 2x to the 1, and I multiply my constant. So 6x is my derivative. The quotient rule is f prime g minus g prime f all over g squared. Different teachers have taught you to remember that different ways. That's really going to be up to you. And then this one is the chain rule, outside function, inside function. So you take the derivative of the outside function, but you leave the inside function alone. Then you multiply all of that by the derivative of the inside function. And that can actually go on into a longer chain. So that would be if, for example, I had y equals parentheses 3x squared minus 5x parentheses to the 4th power. Then the 4th power is my outside function, and the 3x squared minus 5x is the inside. So dy dx equals 4 parentheses 3x squared minus 5x, because I didn't change that inside function yet. Subtract 1 from my power, and I get a 3, times the derivative of this inside function, which is just 6x minus 5. Now you could go back and simplify that, but that's just reminding you what these rules look like. We have trig function rules over here, and these are pretty self-explanatory. I will say the way they have them with an x in there is great as long as that's just an x, but keep in mind that if I had the derivative d dx of sine u, and that just indicates that my angle is anything but just a plain x, then I would have cosine u times du dx. So you would have to take the derivative of the angle, and that's a chain rule thing. Inverse trig functions, exponential and log functions, here are the rules. E to the x is a really easy rule because the derivative of it is just e to the x. If I had e to the u, then the derivative d dx of e to the u would be e to the u du dx. Kind of like using implicit differentiation. Ln, or natural log of the absolute value of x, is 1 over x. Any exponential, which is a number to an x power, is the number to the x power times the natural log of the number. So you see that you just follow the pattern for these rules. Hyperbolics, I'm really not getting into yet. But let's go down here, because here's where I think some of you were struggling a little bit with Chapter 3, was just taking the integral itself. So looking at these rules, start off with our basic power rule. If I have an integral of u, or anything, to a power du. When we did our derivative, we brought the power around, kept the base, and subtracted 1 from our power. Now we're going to do the opposite of that kind of, and you take your base, instead of subtracting 1, we're going to add 1 to the power, and then we're going to divide by the new power. And you always behind an integral put plus c, Because if there was a constant on my function, let's say at the end of it there was a +5, and we took the derivative, that +5 would go away because the derivative was 0. So we don't know if there's a constant on my function or not. So if you look, every single one of these general rules has a C on the back of it. So that is the basic rule. And then you have all of these other rules that hopefully you worked with in Calc 1. Now, some of them you probably didn't touch as much, but you should be at least familiar with, I would say, about right here with these. At least familiar with these. If you're not, I strongly recommend that you go back and you work on some videos for Calc 1, maybe in Khan Academy. I'll try to put a link up for those. But just a good example of something that we worked on the other day, we had some, in section 2.5, when we were working on the problem about the Hoover Dam, we had this integral. Now, granted, and I believe I showed you during that series of videos that you could put this in the calculator because it was a definite integral, which means it has upper and lower limits of the integral. So the problem here is I need you to know how to take the integral first. So we're going to, for the purpose of this video, ignore the 10 and the 540. We're going to integrate 62.4 times this. I need to FOIL this out or box this out or however it is that you multiply, because I can't do this as two separate products. You don't have a product rule for integration. So we have 1250x minus 12,500 minus 2x squared over 3 plus 20x over 3 dx. So just a rule, basic rule. I have a constant here. I can move that outside because it's times the whole function. Integrate 1250x, and I don't separate all of these because I feel like that is unnecessary. I'm going to write this as 2/3 x squared, and we'll write this as 20/3 x to the 1. And we have an x to the 1 there as well. So I actually could add those together. I guess I should probably do that. So 1250 would be 3,607.50. So 37/53 plus 20/3 is 3770 over 3, x to the 1 minus 12,500 minus 2 over 3 x squared. All I did was combine like terms. I still haven't integrated. Now, since here we have a 1, then I'm going to bring that up to a 2 and divide by 2. The number in front of it didn't change. And we still have 62.4 out here. Minus, this doesn't have an x at all, which is like having x to the 0. So 12,500 x to the 1 over 1. Minus, plus 1. So I'm going to have x to the 3rd over 3. And I have a 2/3 here. Plus c. There's my constant, that nebulous constant that we don't know about. So you guys, this was what the basic rule was. And then you have your 62.4. I'm going to say 3,770 over 6x squared minus 12,500 x minus 2/9 x to the 3rd plus c, which for the purpose of this video is good enough, just showing you how to get the rules down here. Okay? So again, I'll try to make a link for Khan Academy, but please go practice these if this is where you were struggling in Chapter 3. If you were struggling because of the concept of how to set up the integrals, then we will talk about that again in a later video.